In the last video, we developed a sort of reverse power rule for finding antiderivatives of x raised to some power. And in that video, we noted that that rule does not apply when the power is a -1. So let's start this video by looking at what happens in this case. Recall that x raised to a negative power means that x is raised to, in this case, 1 in the denominator, right? That's the definition for negative exponents. When we went through derivatives, we said that the derivative of the natural log of x is equal to 1 over x. So we might like to say that the antiderivatives of 1 over x is going to be the natural log of x plus c. But there is a slight technicality here in that we're allowed to put negative numbers into x in this function, but we cannot put negative numbers in for x in this function. So the appropriate antiderivative is going to be the natural log of the absolute value of x plus c. So this is the one exception to that reverse power rule that we've been using when looking at x raised to some sort of power. Okay. But this brings up another important point, in that sometimes powers are expressed in ways that we don't necessarily like if we want to use our power rule. So let's look at some of those examples. Suppose we want to find the antiderivatives of 1 over x cubed. We'll keep in mind that the notation with a negative exponent, x to the -3, is the same expression as 1 over x cubed. And this is a form where we can very easily apply our reverse power rule, adding 1 to my exponent. So the new exponent will be a -2, and then I'm going to take a coefficient of 1 and divide by that new power. So a coefficient of -1/2, and add c. And about 4 over x to the 7th dx. Well, another way of writing this fraction is 4 times x to the -7. Again, the negative exponent puts the variable into the denominator, raised to the 7th power here. So using our reverse power rule, we want to add 1 to -7, so it's x to the -6, and take 4 and divide it by this new power, which will reduce to a -2/3, and add c. Another instance where we might want to manipulate powers are problems involving roots. Right? So here we need to remember how roots relate to fractional powers. Recall that the nth root of x to the m can be written with the fractional power m over n. So in this particular problem, we have an unwritten 2 here for the square root, and x is raised to the 1st power. So here I want the antiderivatives of x to the 1/2. So add 1 to the power. 1 divided by 1 divided by the new power, 1 divided by 3/2 is just 1 times the reciprocal. So the antiderivatives here are 2/3 x to the 3/2 plus c. about the fifth root of x to the fourth. The fractional power here is 4 fifths, right? The index is the denominator, the power on x under the root is the numerator. So to find the antiderivatives here, I'm going to add 1 to 4 fifths. So that's x to the 9 fifths. And then 1 divided by 9 fifths, again, is 1 times the reciprocal, and add c. Okay. Let's just look at one more example. Suppose we have 1 over, let's make that a 4. 1 over the fourth root of x cubed. Well, this is the same thing as 1 over x to the 3/4. But to use my power rule, I don't want to work with 1 over x to the 3/4. I want to work with x to the negative 3/4. Right? These three expressions are all equivalent. So to find my antiderivatives, I'm going to work with this form using the reverse power rule. So negative 3/4 plus 1 is 1/4. And then I'm going to take 1 and divide it by this new power. So that's going to be 4 x to the 1/4 plus c.